As you can see, we're going to cover project estimating. Well, first up, what exactly is estimating? Unfortunately, many people associate it with the word guessing, and as you'll learn in this module, estimating has added science to that art. Starting with the definition, an estimate is an approximation of project time and cost targets that is refined throughout the project life cycle. And the term estimating is defined as it uses a range of tools and techniques to produce estimates. Fairly obvious, as I think you'd agree. So what exactly is this range of tools and techniques? Well, there are 4 of them. There's analytical, also called as bottom-up, comparative, also known as top-down, parametric estimating, and 3-point or PERT estimating. We're going to look at all of those, as you might imagine, and a very brief description of a modern technique which is often used called Monte Carlo analysis. Okay, so what is estimating in terms of your project? Well, first of all, the business plan or business case needs to remain viable throughout the project. And from the work we've already done, you know that it looks at project cost or budget over a period of time and the realisation of benefits. You could also add risk to that mix as well. So clearly estimates are involved in some way in order to check that the business case is viable at the beginning and continues to be viable throughout the project. Estimating has a large influence on your project's cash flow and funding. After all, the cost and time elements of a project are all based on estimates. And of course there's the work that's carried out in order to create the products and how many resources are needed, human and non-human, in order to complete this work. These too are based on estimates. Now, it's an absolute fact of life that since estimates are an approximation, then you will want to revisit estimates throughout the project. So re-estimation should be done throughout the project. The reason why this would be necessary is because at the beginning of the project, when you produced your first estimates, it was based on prior assumptions and known constraints at that time. Well, as the project continues through its phases, prior assumptions often prove to be slightly different to what we originally thought, and constraints may turn out to be different as well. Of course, partway through the project, you're gathering new progress information, which you'll compare to the project management plan, which in and of itself was based on estimates in the first place. So in the light of new data, we will still be using estimates to help establish the true status and the future forecast of our project. Now, estimating is used for baseline and progress control, meaning that the project management plan was baselined after its approval, along with any other management documents or information of the project, and this is used, as I've just said, as a reference point against which to monitor actual progress versus planned progress. And any variances, of course, need to have corrective action taken. Even that corrective action will be based on new estimates. So estimating is used originally to create the baselines, and second, for ascertaining progress and taking control actions if and when needed. I'm afraid it needs to be said, but when you look at the reasons why projects fail, one of them points to the fact that poor estimating continues to be a major cause of project failure. Well, don't worry, because this module is going to share with you industry best practice estimating techniques. So if you apply this back in your workplace, you should find a great improvement in the application of your estimating techniques. So let's now look at estimating work, cost and duration. And this is the source of a big confusion for many people. Those first entering project management, as an example, and asked to give estimates, apart from feeling quite nervous for the first time, they're often asked how long will this take, because that's what senior managers want to know for the most part, and how much will it cost. So instead of going into estimating, the novice project manager would be able to do not much more than just give their best guess. And that really isn't an estimate, is it? One of the reasons why it's difficult is because task duration, and that refers to the project duration as well, is actually the last thing that you're able to know about. As an approach which will make you better at your estimating immediately, the first thing you need to look at is the work effort, or work hours, or work days over a period of time, and then knowing what, for example, labour costs are, and the cost of any materials, equipment, or other facilities, then you can determine what the cost of a task is. Once you know how many people can carry out the work, that in and of itself will allow you to calculate the task duration. If you had one person cutting the grass, starting bottom left-hand corner, it'll take a certain amount of time because the work effort to cut the grass is fixed because of the size of the grass, and you've only got one person. If you added two people and the second person could start top right of your lawn, then all other things being equal, the task will only take half as long. And that's a rule of nature. However, let me take that to an extreme. If you had four people mowing the grass, for a start with, they'd have to agree who cuts which bit and to make sure they don't get into each other's way. And it might be you've only got 3 lawnmowers, so that one person takes over from another when the other one gets tired. So there are very many other variances when you start to consider the actual resources that are available. You'll normally find that your early task durations should be based on one person. And then when you go to negotiate what resources are needed and you find that they can offer you 2 people, then you can then adjust your task duration based on that. It's a dangerous game to assume that because you happen to know there's 4 engineers sitting around not doing a lot, that the task duration will be based on 4 engineers, in which case the task won't take very long at all. And this is one task of many throughout the project plan. If that happens for all of the tasks, you'll end up with a project plan that might be approximately right for the cost, but it'll certainly be way out in terms of the duration. So a reasonable approach here is to try and estimate average amounts based on the available work effort and indeed productivity. You can see there are many factors coming into play here. Productivity is only one part of the equation of a particular individual. It could be their knowledge, skills and experience. More experienced people tend to get tasks done quicker because A, they know the shortcuts, and B, they've got very good at it. And many a project estimate has been thwarted by the estimator assuming they would get 2 senior engineers and instead get 2 junior engineers because they're the only ones that are available. And now I'm going to introduce the biggest killer of all, which is something we've all been guilty of throughout our lives, me too. Now we know there are 365 days available in each year. So when we're thinking about applying these work hours, be aware of this. Now there are 104 weekends in an average year. Now, if you're telling me your team always work weekends, always do overtime, then you'll have to factor these numbers I'm going to generate. So on average, let's assume most people work 5 days, Monday through Friday. So those 104 weekends need to be factored in to how efficient or how many available hours people have got. There are also 8 bank holidays in the UK. Again, depending on where your labour force comes from, many other countries often have different religious celebration days where they will not be available for work. So assuming these numbers here, that leaves 250 available weekdays, Monday through Friday. So you can immediately see this is a much smaller figure than apparently the 365 days we've got, because this project will take about a year, let's assume. So what other factors we need to consider? Well, again, in the UK, typically, you'll get 30 days annual leave entitlement. Yes, I know that may vary in different industries, for example, and in which case you need to factor that in. But let's run with 30 days because it's a reasonable average. And typically, 20 days off for sickness and training. Again, these numbers have been derived from statistical analysis done throughout the UK. And unbelievably, typically 30 days are lost due to meetings. Now, this is management meetings in general rather than specific meetings for the project. You may be having a technical specification meeting or something. That doesn't count here. This is just the overhead of you being a corporate employee and the business needed to be run and management overheads need to be tightly controlled, and you'll be told that you must attend some meetings. For example, a monthly group meeting if you happen to be working within engineering, as an example. So factor these in, it leaves just 173 productive days per year. Quite a surprise, isn't it, how that shrunk from 365 days. Let's just do some sums on this. 253 divided by 173, so that gives 70% productivity, which is about right. So what is the impact of work hours, time and costs based on these calculations? Well, as an example, if you estimate a task work effort to be, say, 10 days worth of work, then the task duration for one person based on this is 10 divided by 0.7, giving you around 14 days of duration. Put another way, if the team member is in the office, in other words, from the moment they turn up in the morning until leaving at the night is 10 hours, then their productive work will be about 7 hours on average. And in case you're thinking about yours being a small, simple project, going back to what I said at the beginning of this slide, if any of this data is different for the context or the industry in which your project's being run, then you'll need to change that factor. So, 7 days of work effort will need 10 days of duration, as it says here. So in the case of this, 7 days of work will need 10 days of duration. So my advice here, based on what I said at the beginning, is that always estimate work effort first, and then and only then, once you know how many people will be carrying out that work effort, can you determine what the task duration will be. Very important point, this. And just a final general point on estimating. Now, thus far I've been talking about work hours and hence labour costs, since it is typically the largest cost contributor to a typical project. However, in addition to labour costs, don't forget the cost of non-human resources such as materials, which tend to get used up, consumed if you will, in the process of making or creating the products, equipment used, test equipment, welding equipment, anything else, the use of facilities, for example demonstration rooms or rooms booked for brainstorming and so on. It's worth just mentioning that the project environment will hold sway on exactly how much of this you need to add. In many organisations, aspects such as labour cost and facilities are simply treated as an overhead, in which case when you come to estimate task durations, the only thing you're interested in is how many work hours and how many people you can get. Yet again, other organisations cost out their labour at a standard rate, so much an hour or so much a day, and include facilities such as meeting rooms and equipment, to mention two, as provided free to projects. As in all things, each project is unique, each organisation is unique. This slide shows the correct approach to estimating, but you need to factor in the exact context of your project. Let's move on. Now, the estimating funnel, I touched on the fact that estimates are very inaccurate at the beginning of projects, and the way in which this is normally presented is the so-called estimating funnel. Now, estimating in the early phases will normally add contingency allowances, simply because of the wide spread, as you're about to see. Now, the estimate used within the estimating funnel is a representation of the increasing levels of estimating accuracy that can be achieved as you move through the phases of the life cycle. And let's remind ourselves, an estimate is an approximate calculation. So here we go, based on this estimating accuracy scale here. During the concept phase, you saw from my earlier slide that it will be plus or minus 50%. As we move into the next phase, that of definition, you'll recall I said that the variation in estimates should be around plus or minus 30%. When it comes to development or implementation, although it starts off at plus or minus 30%, you'll get more and more accurate as you reach the end of the implementation, down to plus or minus 5% or so. And of course, once we do handover and closeout, since everything's been done, it's not an estimate anymore, it's an actual, and therefore you'll have zero deviation. It'll be the truth, the whole truth, and nothing but the truth. So do remember this, it's called the estimating funnel. These numbers I've given you generally tend to be accepted, although depending on the source of information, you may find small variances in them. As an example, you might often see proposal, budget, sanction, control and tender as various different stages in a project, and there the percentage accuracy can vary at the very beginning when you're asked to give a proposal, 30% to 50%. Yeah, a budgetary figure would be something like minus 20% to plus 35%. When a bid is actually sanctioned and agreed, we're expecting minus 10% to plus 25%. When you're monitoring and managing during that, minus 5% to plus 15%. And when you're asked to tender for a piece of work, surprisingly, minus 2 to plus 5%. Now, you don't really need to memorize these figures. They're general examples of what you may find in different industries. The ones to remember, certainly for the exam, are using the life cycles of concept, definition, development, handover and closeout. So remaining on the estimating funnel, why exactly do we get this difference in estimating accuracy? Well, during concept, fairly inaccurate estimates due to the lack of available information. As I said earlier, the requirements will be fairly top level, not yet prioritised, so estimates by their very nature will have a wide spread. Also, of course, the requirements lead directly to the scope, what's included, what isn't. And this will be very fuzzy during concept, where differing opinions would state different ideas of what exactly the scope of the project is. So it's quite understandable to have a widespread in estimating accuracy during the concept phase. When it comes to the definition phase, remember this is where we create the project management plan, you will get improved accuracy as the planning process starts. You'll still have some basic assumptions to make, constraints to assume, and any dependencies, internal or external. And all of these will still give uncertainty to the type of estimate that you can create. However, as you go through definition, it moves from around plus or minus 30% to plus or minus 20% ready for the development and implementation phase because of these aspects here. What about the development and implementation phase then? Well, you'll have detailed stage planning done during here, particularly if you're splitting the development phase into different stages. And monitoring of progress data throughout these stages will improve the estimates. However, there will still be some uncertainty even during development, and the uncertainty causes are usually around change requests. These can be raised by pretty much anyone, although the most likely source is the customer or users. As a result of understanding more about the project, these change requests will have a direct impact usually on scope and thereby also on work effort, time and cost. So some change requests will not be accepted. Remember, they have to be authorised by the appropriate authority before they're implemented. And of course there's ongoing risks and issues. The basic difference here is that an issue is something that has already happened and a risk is something which may or may not happen at some point in the future, but both of them give rise to uncertainty. If during development an issue is suddenly raised, then that will have an impact on the project, whether it be time, cost, work effort, or just about anything else, and that issue has to be worked and resolved and minimised. However, as a result of that, the issue may still have a bearing on the remainder of the project. Whenever possible, each risk should have a response determined that needs to be worked on now to either reduce or remove the impact and or the probability of that risk happening. However, in the real world, risks still do happen. As you go through the development phase, because you now understand quite a lot more detail, new risks will arise with either a bigger impact, a smaller impact, or a different impact, and the probability of existing risks may get less likely or more likely, and of course brand new risks will be identified. So all of these aspects during development can result in some degree of inaccuracy within our estimates. However, because we're actually doing work, then the results from that work can be tested to improve forecast estimates. So as a result of finding out what product 6 actually took to implement and complete, we now have a better understanding of product 7, 8 and 9, for example, that still need to be done. When it comes to handover and closeout, we've actually done all of the work, and therefore there'll be zero spread on the estimates. But what it does mean is that although we give accurate estimates, it's because it's based on experience and hindsight. But this has a value, particularly in lessons learned, because these actual results that we've now got for this particular project can be used to improve similar future projects. Thereby, when future similar projects start off up here, lessons learned will tend to bring down this spread closer to zero. Now, in case it needs to be said, as we go through the project, at the very first moment that estimates are shown to be in error due to actual experience, for example, product 3 was supposed to take 6 weeks and cost £50,000, but it didn't, it took 7 weeks, but it only cost £40,000, then the project should be replanned because now the future forecast of that project can be based on better data. And this situation should continuously happen throughout the project. It would certainly be best practice that as you get to the end of each of these phases, all estimates should be revisited and updated. And certainly when you get to the end of each development stage, the project management plan should be updated, and of course the next stage plan can be created based on this new and improved experience. You can see how this forms the so-called rolling wave approach to both planning and estimating. And another reason why the estimating funnel, by a law of nature if you will, must get more precise in terms of estimates as the project progresses through the various phases.